Hi, I'm Adam Klivans, director of the NSF Institute for Foundations of Machine Learning, a center grant whose mission is to come up with powerful tools that you can use to build advanced generative AI models, such as LLMs, diffusion models, text-to-image models, and models that work in other domains, including biology and health. I'm joined here today by my co-director, Alex Dimakis, who's a professor at UC Berkeley, and also Sanjay Shakkottai, who's here at UT Austin. We wanted to highlight some of our big successes through the first 5 years of IFML and talk a little bit about some of the things that we're excited for in the next 5 years. One of the things I'm most excited about at IFML is using AI to accelerate scientific discovery. So instead of having to wait around for scientists to do complicated lab work to come up with new vaccines and therapeutics, we can run simulations in software to figure out how we can engineer new therapeutics to treat cancer or new vaccines to fight disease. We're hopeful that we're going to come up with the next generation of drugs for a wide variety of diseases. Alex, can you tell us a little bit about how IFML has contributed and how important it is to build new LLMs?
AI is transforming every aspect of society and science. And I think that many of the innovations are happening behind closed doors. Most industry labs are not releasing any data sets. That's why it's extremely important that this research or some of this research is done with open data, and so that it enables replication, accountability, transparency, and enables an open ecosystem that has to be done by our university and research community. Our institute co-led the first DataCom project, which curated the largest public data set of images and text. And that was a key aspect of OpenClip, which is one of the most downloaded Python packages in the world. It has been used in Stable Diffusion. And our last effort was called OpenThinker. Well, we created the best reasoning public data set used by research labs, university labs, and many companies to train reasoning models with open data.
Alex, what I don't think people realize is the importance of the actual data that you're feeding into these models, the type of models that power something like ChatGPT. What sort of techniques are we using here at IFML?
If you just take raw data, you're going to have very poorly performing models. All the data curation effort is done by algorithms and LLMs that select, rewrite, verify, and filter data available on the internet. The intelligence in data curation focuses on selecting what to keep versus what to throw away.
Sanjay, we've been talking about text here, but I want to ask you about images. Tell us some of the things that you think are most impressive that we've accomplished over the last 5 years.
So we have been looking at this class of diffusion models, which allow us to edit, personalize, and stylize images. So we have developed state-of-the-art methods which enable these to be done in way less than a minute. We have collaborated with Google to productionize this across various platforms, including their Pixel platform.
You were able to come up with these clever algorithms. It's amazing that Google has decided to use them. There's a lot of math behind coming up with these algorithms and these models.
It all starts from the math in my mind. These things are at such large scale that you get the math wrong, you're going to waste a lot of computation and also get poor quality results.
On the educational front, IFML has developed a really advanced curriculum for generative AI that powers our online Masters in AI program here at UT Austin. The Masters program is going to have thousands of students in it as of spring 2026, and it's teaching our students all the advanced techniques that you need to know in order to do generative AI and deploy generative AI systems across many domains. Sanjay and Alex, thanks for joining me today to talk about all of the things that we're doing at IFML. I'm really excited to work with you guys over the next 5 years. I'd also like to thank the National Science Foundation for funding all of this work.